Hello, in this video we're going to talk about multiplayer games and how multiplayer works in Unreal Engine 5. By the end of this video, you should have a general understanding of the logic behind multiplayer, and you'll have a better understanding of the vocabulary used in Unreal Engine 5, as well as a high-level idea of how to implement them in your games. So in this, we're going to cover three different modes of games: single player, peer, and then we're going to cover multiplayer games, and I'm going to discuss two different ways of doing it: peer-to-peer and client server. The idea behind multiplayer, whenever we talk about it, is whenever you play a game online with someone else. So we're not referring to split screen or playing against someone else on the same machine, because that doesn't really contribute to multiplayer games. So let's talk about single player games, a game like Witcher or Elden Ring, when you're actually playing it yourself and you're not playing with someone else over the internet. In those kind of games, you pretty much download a copy of the game on your machine, and all the game logic is running on your computer. All the computation of the damage that you're doing, and all the different stuff that you're doing in the game is all being calculated on your computer. And whenever it comes to cheating or anything in the game, it's whatever that happens on your machine. So it doesn't really matter too much. And that's why you have like cheat codes and everything in single player games where you can actually apply them, and it doesn't really matter because you're not really ruining the integrity of the game for anyone else. So in essence, that part of single player games is much more simpler, and you don't have to worry about anything else. So now let's talk about multiplayer when you're actually playing a game online with your friends. You can take a game, for example, like League of Legends or Dota, and let's say you're three friends that want to play the game together. So in this case, it's a bit different because now each of you are running the game on your machine, but at the same time, you want to be able to see what the other player is doing, even though they're kilometers away from you. So let's say you're again playing League with, and this is player one. So whenever player one moves from point A to point B, you got to keep in mind that that's only happening on his machine. So in order for player two to know that he's moved, he has to send a message from his computer to player two saying that I moved. And that's how the game on player's two machine knows that player one moved as well. So player one also needs to let player three know that he moved as well, so the game updates on his machine as well. This is called the peer-to-peer model of multiplayer, because everyone has to let every other person know that whenever they do an action. So you can imagine when player three moves, then he has to let player two know, and he has to let player one know. And the same thing happens if player two moves. So he has to let player one know, and he also has to let player three know. And you can see that whenever there are a few players, this way of coding multiplayer games will work. It's not that complex, but you can imagine if you had 10 different players, 20 different players, just keep going, or 1,000 players, then you have a lot of these arrows going in and out from all the players, and that's going to take a lot of network bandwidth, because if imagine there's 1,000 players, and then player one needs to receive events from 999 other players here to update their game, and you can scale that up to 1 million players, and this method just won't work anymore. So again, if you have a small enough game, then this method could be a way of doing it. The other downside of the peer-to-peer method is that all the different instances of the game are different from each other, and you can't really point to one game and say, this is the source of truth, this is what the real game state. Because whatever player one is seeing on his screen is not the same as what player two and player three are seeing on their screen. Because whenever player one moves, his screen is updated first, and by the time player two receives that move command, he's probably moved a little bit. So now player one's game is not the same as player two, and it's not similar to player three. So this is another downside of such a methodology. So let's take a look at the next method here. Right, so this method is called the client server method. And imagine again, we're playing League again, three different friends playing League or Dota or any other game that you can think of. And the way this works is that one player would be the host. So, one of the players is going to say, okay, I'll host this game. And, they launch the game on their computer and the other people join his game. The way this works is whenever player one wants to move, he sends a message directly to the host, and he doesn't need to send any other message to player two and player three. So we'll say player one moved here. And now the host, once he receives this notification, he'll let everyone else know that player one moved. So he'll let player two know, and he'll let player three know that one moved here. And this way, all the machines don't need to communicate with each other. And the game on the host's machine is the one that actually notifies everyone else. And this is called the client server method because all of these are considered the client, and this host is considered the server. And this is specifically called a listen server. And this is something you'll come across whenever you're in Unreal Engine. And the listen server basically means that there's an actual player playing the game who is the host and the server. There are some downsides to this method as well. What happens if you have, millions of players, and then you have like this one game that's actually the server, the host, and well, it's not going to have enough bandwidth to be able to handle all those different players' messages coming in and all those updates coming into the host and going out to all the different computers. And the other downside to this method is that the host will have an advantage over everyone else because his game is updated the fastest, so he's going to have the least latency compared to everyone else. So they're going to have a major advantage, especially if you consider competitive games. This method will not work at all. Now, the alternative to that is instead of having a player host a game, you'll actually have a dedicated server that would have the game, would be running the game, but it won't have it rendering the graphics of the game. No one's actually playing the game on the server, but all the game logic and everything else is being run on the server. And the idea is the same thing, where the player would send the message to the server, and the server would let all the other players know that player one, for example, moved, or player one attacked, or player one died. So all of those would be done on the server, and the server will have much more computational power as well. And this is what a lot of larger MMORPGs or large competitive games use, because this is very scalable and you can have as many players as you want. Now let's talk about a concept called authority whenever we're talking about the client server model. And the idea is the following. So you don't want the players to be able to cheat or break the game and do things that are illegal, because now you have a lot of different players playing on the same game, and you need a way of ensuring that everything is working properly. So in this method, we're saying that the server has authority. That means that this is the game running on the server is the source of truth, and everyone needs to check whenever they want to do an action, check with the server if that action is valid or not. So let's say if player one wants to move from A to B, it calls the server and it says, can I move from A to B? And if the server does some calculation on its game state, and if it sees that the move is valid, it allows player one to make the move. So it says, it's okay, you can go ahead with the move. And then player one updates the screen, and the player is able to move from point A to point B. And at the same time, since this is validated, the server also lets player two and player three know that player one moved from point A to point B. And this process of letting everyone else know that that move happened is called replication. And you'll see this verbiage in Unreal Engine as well, and you'll know what it means. So we're replicating to the other players, saying that player one moved from point A to point B. And this process this is what is called authority. It means that the server is the source of truth, and player one is asking the server whether it can move or not. This is one way of doing it, and maybe you're thinking this may slow the game down a little bit, and you may be right, because player one, whenever, let's say, the player clicks on W or presses W down to move forward, So let's say that takes like, 50 milliseconds, and then it needs to call the server. Let's say that takes another 100 milliseconds, and then the server responds in 100 milliseconds. So it'll take 200 milliseconds for the player to move from point A to point B, and this causes a bit of a latency. And the farther away the server is, obviously, the longer it will take to actually send the message and for send a message to come back. I'll talk about a different method to do this as well after the next section. So Unreal Engine uses authoritative client-server model. So basically, the source of truth is the server, and the players will need to update the server whenever they want to make any kind of action. Even when you make a single player game in Unreal Engine 5, it's still using the client server model, but in a single player game, the server and the client are the same person, and that's how Unreal Engine 5 handles it. The way the player requests for the server to validate its movements, it doesn't have to be like the way we talked about previously. There are other ways of handling it as well. So for example, one other way, just for context, is that the player one, whenever let's say they click a button to move, what the game would do is it would make the move, but it would also call the server and says, I'm making this move, but it doesn't need to wait for the server to validate. It actually makes the move, and then the server comes back. If it validates the movement, then everything is good. It's not a problem. But if the server figures out that the movement was illegal, then the game for player one would roll back. And that's another way where you can actually reduce the latency and lag, and it's called prediction. I don't want to go too much into it, but I just wanted to show you that there is more ways to handle that kind of thing. But the idea of sending a message to the server and the server replicating that same movement to all the other players is something that Unreal Engine handles. And you're able to code it for different stuff, and some of the things are automatically handled by Unreal Engine 5. With that, I will end the video. If you have questions, feel free to put it in the comments. Thanks for watching.